30 centimeter cube of 0.1 molar aluminium triisonitrate 5 solution is reacted with 100 centimeter cube of 0.15 molar of sodium hydroxide solution. Which reactant is in excess and by how much? Solution. Before we proceed, if you are yet to subscribe to this channel, kindly do that, and as well click on the notification bell so you don't miss out on more videos like this. There is also a link to our Telegram channel in the description box, which is being displayed on the screen right now. You can join our channel via the link for better communication. In the question above, we are to determine which reactant is in excess and by how much reactant, that is the volume by which the reactant is in excess. So the first thing to do in attempting questions like this is to write out the chemical equation showing the reaction between the two solutions. So we have aluminium triisonitrate 5 reacting with sodium hydroxide to give sodium nitrate plus aluminium hydroxide. So after writing down the chemical equation, the next thing to do is to check if the equation is balanced. So let's start with aluminium. We have one atom present in the reactant side. In the product side as well, we have one. For nitrogen, we have 3. These 3 will be used to multiply the subscript here, which is 1. We have 3, and here we have just 1. So to balance nitrogen, let's add 3 to the product side. So nitrogen is balanced. Let's check for oxygen. We have 3 times 3, that's 9. So we have 9 plus 1, that makes it 10. Checking here for the reactant product side now. 3 times 3, that's 9 plus we have 3, that makes it 12. So what do? Let's add, since we have just 1 here and we have 9 here, we add 3 here. So this will become 9 plus 3, that's 12. While in the product side as well, we have 12. So for sodium now, 3 is affecting sodium as well. So we have 3 atoms present in the reactant. In the product side, we have 3 atoms present as well. We've checked for oxygen, and for hydrogen, 3 atoms is present in the reactant side, while in the product side we have 3 as well. Hence, we can say we have a balanced chemical equation. So the next thing to do now is to state the number of moles, that is the ratio in which they are combining. So for aluminium triisonitrate 5, we have 1 mole. Here 3 mole. The number of moles is gotten from the coefficients of the compound. Here we have 3 and here we have 1. So now to determine the one which is in excess, we need to know the volume of each of them that reacted. Then we can determine the one that will be in excess and the one that will be used up completely in the reaction. So let's start with aluminium triisonitrate 5. In the above question, we are made to understand that 30 centimeter cube of 0.1 molar of aluminium triisonitrate 5 was being used. So we need to determine the number of moles of aluminium triisonitrate 5. So we'll say number of moles. So we have to determine the number of moles now. To get the number of moles, we'll be using the formula that says molarity equals moles divided by volume in centimeter cube multiplied by 1000. Don't forget we are finding moles. Moles is what we want to determine. So we'll make moles the subject. Hence, moles will be equal to, making moles the subject here, molarity times volume in bracket centimeter cube divided by 1000. Say moles of aluminum nitrate equals the molarity, which is 0.1, multiplied by the volume 30 centimeter cube divided by 1000, and this gives 0.003 moles. So we've gotten 0.03 moles. Now for the second reactant, which is sodium hydroxide solution, we'll have to determine the number of moles as well. So to do that, using the formula above, so we just say moles of sodium hydroxide equals the molarity, which is 0.15, times the volume 100 divided by 1000, and this gives 0.015 moles. So with this, now we've determined the number of moles of each of them that reacted. Now let's see, the next thing to do now is to determine the limiting reactant and the one in excess. The limiting reactant is the one that will be used up completely, while the one in excess is the one that won't be used completely at the end of the reaction. Based on the equation above, if we have, to start with, if we have 1 mole of aluminum nitrate reacting with 3 moles of sodium hydroxide, what number of moles, or what is the number of moles of sodium hydroxide that will be needed to react with 0.03 moles of aluminum nitrate? So let's do that. So say for 0.003 moles of aluminum nitrate, X moles of sodium hydroxide will be required. Let's do that here. Okay. So what is X? We want to determine X now. So here X, to get X will be equals multiplying indirectly, X will then be equal to 0.003 moles multiplied by 3 divided by 1. This is the ratio in which they are combining. So and this equals 0.009 moles. Now looking at this, we have 0.009 moles. That means out of, if we use all of the aluminum nitrate, the amount of sodium hydroxide that will be needed is just 0.09 moles, and we have 0.015 moles. That means sodium hydroxide is in excess. We can stop here and we can move further to check for sodium hydroxide. We can check with sodium hydroxide again, taking sodium hydroxide to be the limiting reactant, and see if we'll be having aluminum nitrate in excess. So let's do that for 0.015 moles. So now let's use Y to represent that. Y moles of aluminum nitrate will be required. So here Y will then be equal to 0.015 multiplied by the ratio, okay, moles, the unit, multiplied by the ratio in which they will be combining, that's 1 to 3, so 1/3 equals 0.005 moles. And mind you, we only have 0.03 moles given. So that means that we can't work with sodium hydroxide, that is, we can't use all of sodium hydroxide, hence we'll be needing more of aluminium nitrate. So this makes aluminium nitrate to be the limiting reactant and sodium hydroxide to be the solution in excess. Hence, so now since sodium hydroxide is in excess, that's the first part. In the question we are asked to calculate the volume of the solution in excess. So we need to determine the volume of sodium hydroxide. So to determine the volume of sodium hydroxide in excess, let's calculate the number of moles that will be left at the end of the reaction. Let's say amount of sodium hydroxide in excess equals the initial amount given, which is 0.015, minus the amount that will be used, 0.009 moles. So this gives 0.006 moles. So the amount in excess is now 0.06 moles. And then the question we are asked to give the volume that will be in excess. That means we need to convert our moles to volume. And how do we do that? We'll go back to the formula we used earlier. That is, molarity equals moles divided by volume times 1000. Okay, let's rewrite the formula first. Molarity equals moles divided by volume multiplied by 1000. This is if our volume is given in centimeter cube. But if we have our volume in dm cube, we do not need to multiply by 1000. So from here, making volume the subject, since volume is what we need to determine here, we say volume equals moles times 1000 divided by the molarity. So volume of sodium hydroxide in excess equals the number of moles from our calculation, 0.006 multiplied by 1000 divided by the molarity, that is the molarity of sodium hydroxide, which is 0.15. So calculating this, we have 40, and the units, don't forget we are dealing with centimeter cube, working with centimeter cube. Then this will serve as the final answer. Hence we can say that this implies that sodium hydroxide is in excess by, that is the volume in excess now, 40 centimeter cube. And that will be all. So with this, we've determined the reactant that was in excess and the volume by which it was in excess, which is sodium hydroxide by 40 centimeter cube. And that will be the end of the solution to the question. Do not forget to subscribe and as well click on the notification bell so as to be notified as soon as new videos are being released here. There is a link to our Telegram channel in the description box. You can join our channel via the link for better communication. And do well to leave your comments in the comment section below. Thank you.